going to enter what I think should be an exciting culmination here of our time together in this symposium, and take the remaining time and we have this afternoon to look as a group at questions that have been raised over the course of the day, questions that anyone wants to ask now in the chat for any or all of the panel are also welcome. And of course, a lot of interesting overlapping talks. So any questions panelists have for each other. This is just an opportunity for us all to benefit from this forum and these different perspectives for these important questions. I'll get us started here with kind of a broad question that we've sort of touched on. I've seen some discussion in chat thinking about prioritization for conservation, whether it's biodiversity hotspots that aren't very high in carbon or carbon hotspots that aren't very high in biodiversity. It seems part of that discussion I've seen in chat is about how do we make sure we don't neglect one conservation goal or another by focusing too much or too little on one or the other. So I'd like to discuss that a little bit and start with kind of a core question, though, where in an ideal scenario, our data sets would help us inform protection prioritization and restoration prioritization based on sites that are both, right? So first broad question is, what are the high carbon, high biodiversity sites that we should all be cognizant of as stewards and land managers?
I'll just jump in because it's silence. So I think we have the data sets to answer that. It's not something that I've explored. I'm looking at Mark here thinking you probably have what's necessary. And I'd like to shift the frame of reference for the carbon question a little bit away from current stocks versus carbon sequestration and its rate today, and more thinking to whether or not the potential 2050 total carbon would represent the two together in a way that's most useful. I think it does.
I was on the same wavelength. I was thinking, first of all, biodiversity is less interchangeable than carbon. So there's a lot of biodiversity sites that I think are very important that may not have great carbon signatures. On the other hand, I think Chris is right that we need to think about long-term restoration of carbon, and a lot of that could be in sites that are not particularly rich in biodiversity. So with really careful planning, it seems very possible to sort of come up with a template that works for both. Doesn't answer your question about where are the places that work for both, but I do think that's also a pretty answerable question too. So we could do that analysis.
One bit I wanted to add is that we absolutely see that two high biodiversity places have a lot of carbon consistently. One is silt floodplains, which is often underprotected, but there tend to be very rich soils, and you see higher carbon levels there. And the other is limestone areas, which also have a huge number of endemics and are critical, and often where your maple forests, which I think were your highest carbon forests in that chart, if I'm right. Anyway, so those excite me as somebody who's always looking at these things together and trying to understand how we target them. And my question back to you, Mark, because of your comment in the chat earlier, was what are the high biodiversity places with lower carbon? Like what are those geologies and settings that are doing that? And I was like, Mesic? But help me there.
Well, okay, first of all, I would add like peat bogs and mangroves, and I mean there's a bunch of other very carbon dense landscapes that also have great biodiversity. So
marshes.
Yeah. Old forest. I would add all that to the high density carbon and biodiversity. I was thinking of more edaphic communities that are rocky. They don't develop a lot of canopy or structure. They're often sparse vegetation, but they have high levels of diversity. Those were the ones I was thinking of as very important for biodiversity, but not so much for carbon.
Yeah, I was about to say the same thing, Mark. A lot of those glades and other openings with very shallow soils are just packed with endemics because they tend to be small, isolated places where species evolved in isolation. But yeah, they don't have much carbon.
Yeah, and a comment here in chat from Karen Patterson addressing the first question I posed, suggesting that mature deciduous forests on high base status soils and geology would be a strong contender for a valuable place that checks both boxes. Any more discussion on that point before it looks like, Chris, you have something.
Yeah, so our data set was getting a feature in this webinar series, and I want to flag something with respect to these peatlands and flooded forests. They can be really high carbon content, not only in their live tree matter, but also, as was just mentioned, in the soils. Our data set wouldn't necessarily capture that well. So users should know that.
Thank you for that clarification.
And Ryan, I would just, as the plug, I mean, I think that these kinds of things are so important for practitioners, you know, to kind of have those, these things identified, you know, don't ignore this because it's low carbon, or, you know, these are left out, you know, so the more we can do to kind of flag those things, I think there's huge value to it. Certainly to me, who's communicating to a lot of these folks.
I would just also add, that, some of the places I care about, some of those xeric pine stands and so forth, they are not high carbon and they're not high diversity either. But when you think about diversity more broadly in terms of beta diversity across the landscape, conserving those, they become important. And then when we think about landscape scale processes, just back to the interesting paper that from Coweta that looked at the implications of upslope contributing area to downslope forest, it's important to think about the entire landscape and the biodiversity across the landscape, and not necessarily just spots or individual pixels.
Good point, and well taken, I think, by everyone. So having started there, there have been several questions that I'm going to fold into one over the course of the day about management prescriptions and recommendations for people who manage forests, who are trying to accelerate late successional forest traits in Central Appalachian forest stands that are currently in a degraded condition, such as lower diversity or even aged. So what's a manager to do who wants to do the best they can with respect to carbon in a Central Appalachian forest that's mature but degraded?
Well, just in general, I mean, if forests are degraded through, for example, logging of the old trees and by fire exclusion, then a combination of careful thinning plus prescribed burning can be very useful to get the forest back into a condition where growth to large size is more likely to happen quickly.
Ryan, that's an outstanding question. I don't know, and I don't want to speak for others, but I'm not sure we have the expertise in this Zoom room to answer that well. At least I wouldn't claim to. But I would think that the tools Reed just mentioned might help with some kind of advanced regeneration to push forests in a positive direction towards high carbon species and large trees that open up that space. I know restoration efforts like that can be effective. I just wouldn't know which species to treat where.
Yeah, and that leads to sort of another follow-up related question. You mentioned thinning, Reed, and we had a couple questions concerned about thinning creating potential to do unanticipated harm, such as the introduction of invasive species into those forests. And so any thoughts about thinning in a way that does the least harm and produces the most desired results, which are in this case increased space between trees and ultimately higher carbon sequestration in a healthier forest. I'll just start off briefly to give you all some time to think and say, in my experience, when doing commercial thinning, there's just two standard practices that we don't even think about that are just laws of the land. One of those is not to log on wet soils because of the known damage to wet soils. And the other is to put in the black and white in the bid that we put in, or the scope of work we put into a newspaper asking for bids. Budget time to pressure wash your equipment before you bring it on site. So those are two upfront practices to minimize the chance of those sorts of problems occurring with thinning. But I'll stop there and see what other thoughts you all may have with respect to that question.
Well, another general recommendation is to minimize the amount of soil disturbance, which leads to both erosion and, for most non-native invasive species, opens up space for them to colonize. So the less you use heavy equipment, the more cautious and prudent you are with your thinning techniques, your silvicultural techniques, probably the less chance for negative effects.
I've got a question.
Well, I don't know, are we allowed to call on people who are in the audience? I know there are some Scott Bear and Katie Shallows. There's some people who've really thought about this question.
Okay, yeah, I believe, Moira, we can do that. We can give people a window, and that's on you, Mark, for putting somebody on the spot, though. I just think it's okay by me, but.
Hi, this is Katie Shallows, and I hope that Scott Bear is here as well, because he can add much more than I can. In the Central Appalachians, the Nature Conservancy and our partners, we're testing out some new forestry prescriptions that have mostly been pioneered in the Northern Apps, in the Central Apps, to accelerate late successional forest traits. And I want to make it clear, only in places where we can do more good than harm. So in places where it's even aged, and we're not going to create sedimentation issues and so on and so forth, and that these are mostly going to be non-commercial treatments. And so some of those prescriptions look like creating gaps, downed wood, snags, planting to create more structure, planting seedlings in the gaps to create more vertical structure, and so I'm curious. I asked this question because I was curious. As we're putting together these forestry prescriptions, we want to do it from the best available science that could help us with the timing and the design overall of these prescriptions. So I think I'm going to have to go back and re-listen to all of these talks again and to see if I can glean from there. But that's maybe the essence of my question, is like, how can I take from your the research that you presented, your best advice, how do I take that and make sure that we're aiming for that the improvement of the baseline in our forestry practices.
Thank you. Okay, we have a request in chat to talk a little bit more about the concept and phrase Mark raised of wild carbon. And if Chris, do you want to? I'm going to pass you the microphone if you want to articulate your question.
Yeah, I really love the concept, and I did take a look at the report. I'd seen pieces of it before, so I'm glad you brought that up. And I also want to point out that it contrasts young forests with old forests, and those young forests are really young, and they're still experiencing the effects, the legacy effects of respiration of the disturbance-killed material that's blowing off to the atmosphere. They're also approaching a phase where that will peter out, and what will happen is they'll start to be in a maturing phase of the stand with very high carbon uptake rates. And it's juxtaposed then with the old forests, which are experiencing, well, I suppose they were sort of free of severe disturbance, and that may not be the norm for very old forests, which can see large tree fall. So I'm just wondering if we can, you, Mark, or all of us together can talk and think about what happens in between and how. So in other words, that middle phase, not the very young condition. My expectation is that's actually a really high carbon uptake moment in a forest's life. it's not to say that old forests don't sequester carbon and maybe aren't putting a lot also into soils, which they can and do. But I'm also wondering, well, how likely is it that they don't experience a natural disturbance of a large tree fall that succumbs due to aging, and that opens up another carbon release opportunity? So thinking through that would, I think, be really helpful.
Well, I'll start, thanks for bringing that up, Chris. I think that's really important. So I guess the point when the leaf area index is now beyond the respiration. And I think that's the residual respiration versus the new respiration is really interesting part of this equation. And I don't know how much that varies or how much we can control or affect it. So, but it is that point when the leaf area index has gotten there and you're starting to sequester a lot of carbon that I think is sort of the sweet spot we're after. I guess the question I have on it is that the rate is very high, but I don't really know if the volume approaches what the original the undisturbed forest, the volume still seems higher for quite a long period.
Yeah, surely that's true. The old growth forest will tend to have high carbon stocks, live and or dead.
Yeah.
So that's again where we get to, but just it seemed as though it was being presented as if the high carbon uptake was the highest carbon uptake rates from the atmosphere were happening in the oldest stands, and some old stands can take up a fair bit of carbon, but also so can those intermediate aged, in my experience. Also, it's partly because, as you just alluded to, the metabolic respiration rate of the ecosystem is responding to a smaller amount of carbon stock. And so there's less respiration, yet there's very high productivity. And that balance leads to a lot of carbon uptake.
Yeah.
One of my questions for you both was whether or not if all of the science in Mark's presentation has been integrated into the models, you think, sufficiently at this point, Chris, or if you think that there's things happening in the soil carbon particularly area that are missing. And I just think of those rate curves, and you see that leveling off, and it doesn't mean it's not sequestering, it's just leveling, the rate isn't changing, right? So, and I'm just wondering if that's accurate at these old ages based on what the science is showing. So anyway, I'll stop.
Yeah, no, it's a great question. And a few things. One, the degree to which the long-term pumping of carbon into the soil that would be captured by our model might be underestimated. That's one thing. Another thing is that today's forests are responding to, actually in a lot of places, certainly in the eastern US, many things that are causing them to grow faster now than they used to. CO2 fertilization, as we know, can enhance growth. So can a wetter climate. And in much of the eastern US, we've actually seen a long-term trend towards wetter conditions. And so those factors might also be leading to today's growth being accelerated in this baseline scenario in a way, compared to what the historic carbon accumulation, compared to the historic carbon accumulation that we capture in our yield curves, where the biomass withstand age. That is not fully in the way we fit our model. So there could be a conservative underestimate. I think generally it's good to have a conservative underestimate for the purpose of trying to think about how much mitigation of the climate change problem we're having. But if you want to try to maximize your carbon stocks, you might want to go to somebody else, some other data product. There was a third point, I forgot it at the moment, but
soil carbon?
Well, I think I kind of got to a piece of that.
Okay.
Well, I guess the last thing is that the FIA plots are going to, they tend to represent, some curves are really high yielding, but a lot of forests experience that disturbance loss. And so our curves bend downward or flatten in part because of those disturbance losses, but not necessarily all of that carbon is immediately evolved to the atmosphere. Some of it is in woody debris, and some of it can be even, again, in a way pumped into the soil if it's not respired away. And so there again could be a more conservative estimate in ours. And that's actually consistent with what it sounded like you found in analyzing and evaluating our data product, which was in the highest field carbon measurements, our data set was relatively low.
So another question that came a while ago in chat, and I'm bringing it up now because Mark, you recently just referenced leaf area index. And so this question is curious whether there is a way that our understanding and the data on leaf area index and how it changes over time, can that data inform the timing of harvesting for wood products in a carbon neutral way?
Well, I'll start there, but I want to end talking about fire and carbon if we can, because I get very worried that this focus on carbon is going to make us biased against fire-driven systems. So if we can come back to that, I think that's a really great question, because a forest, there's many different forest types, and as they mature and grow in complexity, there's all sorts of ways to optimize your leaf area based on your subcanopy trees and your understory and your herbaceous layers. And I wouldn't want to simplify it. I wouldn't really want to simplify it without a lot more information. I guess the idea is there's probably lots of ways to manage those complex forests that would keep your leaf area relatively high, and it could have to do with your different layers and your different species composition. And I think that's what the person was asking, that is that fertile ground for research? And I think it is myself.
Okay, thank you. Yeah, we do need to circle back to fire. You're right, Mark.
Yeah.
I think there are probably a lot of people on this or listening to this symposium today that either work in that world or think about that world or have a foot in that world. One of my goals for our conversation together this afternoon was to ask the sticky wicket questions and to encourage others to do the same. So one thing, Charles, I heard you say is essentially, there's a role for prescribed fire in carbon smart management of these forests. But as we look ahead at changes in climate and we look back to the mesification that's occurred, where fire managers are in a position where we have increasingly difficult burns to do because of fuel loading and species change, and fewer days to do them each decade. So there's the sticky wicket question is, what are some recommendations to address that reality? Recognizing fire is important and it's getting harder to do and there are fewer days to do it.
Well, I would be interested in, I think that's an interesting question. I'd be interested if any of the fire managers here want to contribute to, but I've thought about that some. And, one of the things, a couple of things come to mind. One is, I don't know to what extent in Pennsylvania this is possible. In some parts of the southern and central Appalachians it is. I've been attending these Southern Blue Ridge Fire Learning Network meetings, and in recent years they have been, they found it more efficient to burn at large landscape scales, in which I was just there in May, and we were looking at some of those burns in the Southern Blue Ridge, like the Nantahala National Forest and so forth. And they can burn 5,000 acres with about the same number of people as they can burn 200 acres, because there are some areas that are remote enough. But they have large tracts of land. And I know in Pennsylvania, they're not, there's Allegheny National Forest up there on the plateau in the Ridge and Valley. I know you have some game reserves there that are pretty large, I think. I don't know whether those kind of opportunities are available everywhere. I know that in Virginia and West Virginia, there probably are. So large scale burning in some of those large tracts of public land seem to be one option for burning even amid the constraints that arise. That's one thing that comes to mind. Another thought that comes to mind too is that, I kind of hate to put it in these terms, but triage may be necessary. There are some parts of the landscape that may just not be worth the effort. It's probably more important to try to maintain some areas under a fairly frequent fire regime, rather than treating, this tract this year and this one next year and putting them on a 50-year rotation or something like that. One burn doesn't restore it. I guess I would rather see a smaller area of landscape actually treated and burned well and restored in a condition that actually is sustainable than to nominally treat more acreage, but in a way that really doesn't make a lot of difference. So those are two thoughts that come immediately to mind.
Thank you. Anyone else or any follow-up questions from the audience, please put them into chat for Charles or anyone else on this topic. Mark, did you have any thoughts for you? You brought us rightfully back to fire a few minutes ago. I was wondering if you wanted to add anything.
Well, I think it's been said. I mean, I think for me, one of the important messages is that different levels of fire can have very different effects on carbon, and there's a real role for prescribed fire in systems that are very flammable in order to keep them from being in order to keep catastrophic fires from existing. Lower levels of prescribed fires could be much better for retaining carbon. It could be better for the mycorrhizal network. I'm trying to figure that out. Charles, you might know more about that. And better for the biodiversity. So I think there's sort of an immediate leap. At least I've seen this in TNC. I'm just being candid here, immediate leap that leaving the forest to grow on its own with no management is the best way to get the most carbon. And I think that may be true in some of our systems, but in a lot of our systems, actually some level of management is important to reduce the effects of disturbances and keep them within a much more manageable level, and that's much better for carbon in the long term. So.
Thanks for that, Mark, and some feedback in the chat from, I'm assuming PGC, I apologize if I'm wrong, but Pennsylvania, maybe Game Commission. PGC is what it says, has been responded to what you said, Charles, to say they've been doing larger scale burns in Pennsylvania. So hopefully that message is being broadly heard, it sounds like. Another interesting comment popped in, staying on the topic of fire for the moment, looking at how flammability might be changing with mesofication. And I think the point here being, as mesophytic species have less flammable litter, are the fire return intervals, what is a natural fire return interval now? Let's see, I'm going to just kick this right to you, Chris, because this is you posed this question, and I'm not doing a good job of collapsing it into a question form.
No, I think you did. It's getting to the question about species shifts and what role that compositional change might play in the flammability of ecosystems, and hence the degree to which that contributes to fire suppression or just less fire over these landscapes. And at the same time, I'm curious about biochar, so I'll throw that in there too, since you're going to have a chance to talk. Does biochar add up with prescribed burning in a way that's meaningful?
Yeah, so on the mesophication question, that is part of mesophication, that the litter becomes less flammable and therefore fire is just less likely to occur. To the point where it can become increasingly difficult to do a prescribed burn even. If we had the forest that we have today and there were no fire suppression and we were back under traditional land uses 100 years ago or 200 years ago, how frequently would fires occur now in those forests? That's a good question. Because we might see a reduced fire frequency compared to what we did historically, just because the landscape wouldn't carry fire in the same way that it did back then. So that's a very interesting question. But anyway, nonetheless, I think that's part of the deal. Mesophication has reduced the flammability, and the thing is, though, most of most of the oak and pine forests in the Appalachians that were historically oak and pine forests still have a lot of overstory oak and pine, and they're casting litter. And so to some extent, there's still quite a bit of flammable leaf litter to carry fire. But as time proceeds and mortality occurs in those overstory trees and they're replaced by maples and black gums and so forth, then it really does become more difficult. There's a window of opportunity to take advantage of it, and I've talked to Don Hagen, and it varies geographically too. Across the Appalachian region, there are dramatic rain shadows and orographically enhanced rainfall areas. So I've talked to Don Hagen there on the Southern Blue Ridge escarpment, where there's like 90 or 100 inches of rain, and the forests there are much further along successionally than those, say, in the Ridge and Valley, where the soils are thin and the rainfall is more like 30 to 40 inches a year. And so the window of opportunity may be closing pretty rapidly in some parts of the Blue Ridge where there's more rainfall and higher rates of mesophication and so forth. So that's one. And in terms of the biochar, I mean, this is an area that, like I said, I have no expertise, and I just stumbled across these papers in preparation. But if I could, let me just look up. The claim is by this. Weighing it all. They're not weighing it all. See if I can find this one. I can't find it right off. But the claim was that in the Great Smoky Mountains National Park. Oh yeah, I know the paper that was done, the research that was done there on pyrogenic carbon was in the aftermath of the Chimneys 2 wildfire. That was a severe, big wildfire in 2016. All the press coverage is on the really severely burned patches, but when you look at the footprint of that fire, most of it, maybe 90% of it, was pretty mildly burned. It was just on some of those wind-exposed south-facing slopes that the severe burns occurred. And so they actually sampled in the severely burned areas versus the less severely burned. And the less severely burned parts of that landscape were more along the lines of what you would see in a prescribed burn. And the immediate input of charcoal was greater from the severe burn. However, if you burn more frequently, the argument was that over time, the input was such that it would accumulate. And in fact, and would accumulate to greater levels if you burn on frequency. So just the continual accumulation would be great. The other important thing to note there that I thought was fascinating was they cored deeper down into the soil beyond the reach of the 2016 wildfire. I mean, that carbon has not been translocated down into the soil yet. And they found large amounts of charcoal as high as or higher than other frequent fire regimes. So it just goes to show it corresponds with the charcoal studies, the fire history charcoal studies, that there has been a lot of burning in the past in the Appalachians. And that has contributed a lot of charcoal to the soils that still remains after hundreds or thousands of years of frequent burning.
Thank you.
Since you mentioned the severe fire effects, Charles, that kind of cues up this other question posed by a practitioner who's dealing with doing some restoration of a severely burned site. And so the question is, what can they do? They ask, is salvaging and planting appropriate? And I'm thinking back too from Reed's earlier comments, opening us up today about trying to avoid simplistic approaches such as dense tree plantings in places where that's not natural as a nature-based solution. But in this case, it looks like they had severe fire disturbance on the soil, exposing many roots, which sounds like I'm remembering a photo from that paper that you're mentioning from the Smokies. And in that severe site, I believe much of the tree roots in the forest were exposed because of the fire severity. So, any comments the group might have on what this person, what resources are available for someone dealing with restoration in a eastern forest that has experienced severe wildfire?
I don't have resources right off the bat, but and there are so many people on in this symposium and just out there in the fire managers, the practitioners who are doing prescribed burning, who have seen burns in a lot of different conditions. who could probably partner with an agency like that and finding ways to address it.
Yeah, not wanting to cut you or anyone off on our panel, but if someone in the audience has suggestions for someone in that situation where they might turn for resources and if nothing else, ideas, please do put it in the chat. I think that could be helpful.
I mean, I would say also that the fire learning networks that the Nature Conservancy puts together, there's a Southern Blue Ridge Fire Learning Network, there's a Central Appalachian Fire Learning Network, as well as the Consortium of Appalachian Fire Managers and Scientists. That's what they do, is they put people together who are practitioners. I see one comment on here they're from a smaller agency working on small scales, but they partner with a larger state agency. I think that's been one of the beauties I've observed in working with fire managers over the last 10 to 20 years, is there's a lot of sharing now of knowledge and of resources around this. So I would encourage you to reach out to somebody like the Consortium of Appalachian Fire Managers and Scientists and seek expertise with people who have dealt with those situations.
Mark, you did it. You hit a nerve, I think, when you pulled us back to fire, because the fire questions keep coming in now. This is great.